Alright, let's do this question. Right, which is still the question on example 1.4.19. Right, so a particle is moving in a straight line and is distant, right, denote in S, in meters from a fixed point in the line after t seconds is given by this equation. This is the displacement equation for the displacement of a particle that is moving in a straight line. Right, so next they want us to find velocity and acceleration of the particle after 3 seconds of their movement. Alright, so we as usual note down everything. So this is the displacement, and they want us to find the velocity after 3 seconds and the acceleration after 3 seconds. Right, so basically before we can look for the value of the velocity and acceleration after 3 seconds, of course we'll need to find the equation first. Let's look at edit one by one. So let's try to look at the velocity first. So to get the velocity function from the displacement, we'll need to differentiate it. So the differentiation of s in terms of t will give us 12 minus 30t plus 12t squared. So after we obtain the function, right, the next thing to do is to substitute 3 into the function. So hence it will give us 30, and 30 here is in meter per second. Refer back to the derivative. It is ds over dt. So s here is the distance, which is in meters, and t here, which is the time, in seconds. So hence 30 here is in m over s. Alright, so for the next one, what about the acceleration when on the t equal to 3? Of course, we'll need to differentiate this function, which is the function of velocity, in order to obtain the function of acceleration. Alright, so this is the function, negative 30 plus 24t. So to obtain the acceleration on during the 3rd seconds, just substitute it here and we'll get 40 meter over s squared, second squared. Right, so that is the solution for this second example.